Hey there, I'm Jadrian, and in this video I'm going to talk about distance time graph. So let's get started. So first, let me draw a graph here. Let me just draw a graph first. Okay, a graph. So a graph here. Okay. So distance time graph, right? So before we get to distance and time, I'm just going to quickly talk about the axis in the graph. Okay, the axis in the graph. So in the graph, we have dv, which is dependent variable, and we have iv, which is independent variable. So the independent variable is always in this x-axis, and the dependent variable is always in the y-axis. Okay, so distance and time, right? So we can have zero distance, we can control the distance that we are going to travel, but we can't control the time. Okay, we can't slow down time or speed up time. Time is constant, so this leads to time is independent. So which means that time is a independent variable, so it's supposed to be in this x-axis. Okay, this x-axis, I'm just going to put here a x and here a y. Okay, y-axis. I'm just going to erase this first, and y-axis. So I'm just going to put this time. Okay, and the distance, as I had said just now, the distance, we can control the distance, right? The distance that we are going to travel. So the distance will be here. Okay, and I'm going to move this to my left a little bit, this to my right, or down a bit. Okay, so keep in mind that if you see time in your graph, the time will be always in the x-axis, which is the independent variable. Okay, so I'm just going to write here y-axis dependent variable. Okay, and the x-axis will be independent variable. You can copy this down on your iPad or on your notebook. Okay, so dv, dependent variable, and iv. Okay, so this is very important when you are going to draw a graph or you are going to plot a graph. Okay, so it's very important. So we know that the relationship between distance and time is that speed is equals to distance over time. Okay, so which means that if you want to increase the speed, we should increase the distance traveled per second, right, per unit time. Okay, which means 1 second you are going to increase the distance that you are going to travel. This leads to increase in speed. Okay, so more speed means you are going to travel a longer distance in shorter time. Okay, so this is just the formula. Okay, so we are going to use this through this whole video. Okay, so let me just draw a table so that we could plot it, and I could tell you what's the characteristics of this graph. Okay, so this will be our table. Well, my time is going to be seconds, which is s, and the distance I will put meter. Okay, so I will put a lot of lines here. Okay, so 1 second, 2 seconds, 3 seconds, and 4 seconds, and my distance will be, I will follow this 1, 2, 3, and 4. So to make it simpler, okay, so to make it simpler so that I could explain it in the less complicated way, so I'm going to start with 0. Okay, a 0 here. So my 1 will be here, 1, 2, 3, and 4, and my distance will be 1, 2, 3, and 4. Okay, so if I want to plot this in a graph, So I'm going to plot this in the graph first. So my time will be 1 second. And by the way, I have forgotten to mention this, is that when we read a point, a coordinate, which is x and y, okay? So in this case, my time will be my x, always in the x-axis, and my distance, whatever this variable is going to be y, okay? So if we want to read a coordinate, let's say if the coordinate is going to be 2 and 4, and my x coordinate is going to be 2, and my y coordinate, which is this 4, it's going to be here, my left hand side, which is the 4, okay? So okay, so always read from x to y, okay? X and y, the x will be the left one and the y is going to be the right one, okay? So in this case, the time is going to be the x variable, so the x-axis. So my x is going to be 1, x is going to be 1 somewhere here, okay? 1, and my y it's 1 2. So I'm going to plot this. Let me just use a blue pen. Okay, so I'm done. Cut, and 2 2 2. Cut, and 3 3. I'm just going to cut it, so I will not be confused by this table. Okay, so let me just teach you a trick. When you are doing a graph, so if you have plot a point, a coordinate, just cross it, okay? So you will not do a mistake, okay? You will not replot it again. So if I draw this in a straight line, if I draw it a line, you realize that this graph is actually a straight line, okay? A straight line graph, okay? A straight line graph. So what it says is, so what it indicates is that the gradient is going to be the same, okay? So the gradient here is going to be the speed, okay? So because we have distance, we have time, which you change in distance, because the speed, it's actually delta d, okay? Change in distance and delta t. Okay, change in distance and change in time. So let me just prove it to you. This speed is actually a gradient, okay? So the gradient formula is gradient equals to y2 minus y1 equals to this x2 minus x1, okay? The minus means change in something, which is delta. In physics or in chemistry or in science, the change, we put it in a delta. We put a delta sign like this, which means it indicates the change, which means change in something, okay? So as you can see here, change in this y, which means change in distance, okay? Which you change in x, then change in time, okay? Because change in time means change in x. It's basically the same thing. So this gradient, this line, the gradient indicates the speed, okay? So let me just put this aside first. I might want to draw something afterwards, okay? Okay. So, and again, we have distance, we have time, we will find the speed. So let us just find this. Just let me prove it to you. This whole graph, the gradient is going to be the same, and the speed is going to be the same as well. So let us just do this first, okay? Do 1 and 1. So gradient, okay, I will just put m, because this straight line graph, it's actually y equals to mx plus c, which is the m is going to be the gradient, okay? The gradient. Okay, just let me put this on top. Okay, so yep, so I'm just going to put m equals to y2 minus y1 x2 minus x1, okay? So let us just do this point first, this point 0 0. Let us just do this. Let me just name this as point A, point B. Okay, so point A is going to be, the x is 0, the y is going to be 0 as well. Okay, so the coordinate, the 0, 0, we will call it as origin. Okay, the coordinate. Okay, so this is the coordinate. So 0, 0, we will call it as origin. It's basically the same thing. Okay, so our a coordinate is going to be 0, 0, and our b coordinate is going to be 1 and 1. Okay, so let me bring this down a little bit. Okay, so this will be our, let us just put, we can either put this as x1 and this be x2, or we can also put this as x2 and x1. Okay, so for me, I will always start with 1 first. So x1, that means this is going to be our x2. Okay, and this will be our y1, y2. Okay, or we can put this as y2 and y1. It's basically the same thing. Okay, so if here you start with x1 first, then the another one is going to be y1. Okay, do not put y1, then this guy will be y2. It's fundamentally wrong. Okay, if you want to put x1 first, then just put y1. Okay, start with this. Okay, x1, y1. You can't put x2 or y1 or y1 or x2. It is fundamentally wrong. So let me erase this first. Okay, so this whole graph, the speed is going to be the same, which means the gradient for this whole graph, this straight line graph, is going to be the same. So y2 is going to be 1, so minus y1, which is 0. Then our x2 is 1, and our x1 is 0. Okay, so 1 minus 0 is 1, then which is equals to 1. So the gradient is equals to 1, so 1 ms. Okay, so 1 ms. So in this graph, which means if this car, this table is about a car traveling, which means the car is traveling 1 ms. Okay, the speed is equal to 1 ms, which means every 1 unit of time, every 1 second, it will travel 1 meter. Okay, if travel in 2 seconds, it's going to be travel in 2 meters. Okay, and also this gradient is constant. Okay, constant. So this is 1 ms. Okay, I can prove it to you by this b to c. I can prove it too. Our point b, I will put 2 x is 2, y is 2, and c it's 3 and 3. Okay, so I will put this as x1 again, it's easier. Okay, so let's calculate the speed for these 2 points, the gradient. Okay, so the y2 is going to be 3, the y1 is going to be 2, and the x2 is going to be 3 minus 2. So which means, let me erase this first. Okay, which means if we minus it, will be 1 over 1, it's equals to 1 ms. See, it is the same. So here will be 1 ms as well, 1 ms. Okay, so yeah, if you see a distance time graph, the line is going to be straight, the gradient, which is the speed, is going to be constant. Okay, so that's it for this video. I will see you in the next one. Bye.